Matthews Gatos here. In this video, we're going to look at proving what the derivative of sine x is using limits. So let's get started. So I know using tangent definition number 2, I can find the derivative of any function. So the derivative of f of x is the limit as h approaches 0, f of x plus h minus f of x all over h. So if I want to prove what the derivative of sine x is, I just rewrite tangent definition number 2 using that f of x is sine x. So therefore, the derivative of sine x can be found by doing the limit as h approaches 0, sine of x plus h minus sine x all over h. So let's unpack that a little bit more. So looking at this is the derivative of sine x. So here I have an angle sum. So I'm going to go to my formula sheet, and there's my formula for angle sum. So I know the derivative of sine x is now going to be the limit as h approaches 0 of, now let's break this out. This is going to be sine of x cos of h plus cos of x sine of h minus sine x all over h. Okay, so what I notice is, this has a sine x and this has a sine x. So I'm going to rearrange it using my properties of limits and write it like this. The limit as h approaches 0 of sine x cos h minus sine x over h plus the limit as h approaches 0 of cos x sine h all over h. So I just rewrote that using fractions and also the properties of limits. So looking at this here, I notice I have a common factor of sine x, and I'm looking at the limit as h approaches 0, which is not tied to x. So that means that sine x is really a constant value. It doesn't depend on h. So I'm going to factor it out and bring it up front. So this is going to be sine x times the limit as h approaches 0 of cos h minus 1 all over h. Plus, similarly here, the cos x, the x is not tied to an x to the h value. So if I'm looking at the limit as h approaches 0, cos x isn't affecting that. So that's really a constant, which I'll take up front. So cos x times the limit as h approaches 0, sine of h over h. So to simplify this, I just now have to evaluate or find the answer to those limits. So the limit as h approaches 0, cos h minus 1 over h. So let's look at our toolbox for limits. Step 1, we look at substitution. Well, I can't substitute 0 in here because I divide by 0, not allowed. So factoring, nothing to factor. Conjugate, nope, there's no conjugate here because there's no real roots here. So what I'm going to do is move towards a graphical perspective, which is substituting in insanely close values. I know it can't be 0, but let's look at what happens when it gets really close to 0. So on my graphing calculator, I look at cos x minus 1 over x. And I want to look at the limit as x approaches 0 from the left and the right. So on the left-hand side here, I can see as I get closer and closer to an x value of 0, it looks like my function is going to 0. On the right-hand side, as I approach 0 from the right-hand side, it looks like my function also going towards 0. So I can say the limit as x approaches 0 of cos x minus 1 over x is equal to 0. So back over here, I know that this limit is equal to 0. So I know this is going to be sine x multiplied by 0 plus, let's look at our other limit. So I'm going to look at the limit as h approaches 0 of sine h over h. Again, I can't substitute in 0 because I'd be dividing by 0. Nothing to factor, no conjugate. So let's look at a graphical perspective, which is similar to substituting in insanely close values to 0. So over here, here's my graph of sine x over x. If I want to know the limit as x approaches 0, I look at from the left-hand side. So as x gets closer to 0, it looks like my function's going to a value of 1. From the right-hand side, as I approach 0, it looks like my function also going towards a value of 1. So since left-hand and right-hand equals, I know the limit as x approaches 0 of sine x over x is equal to 1. So let's go back over here. Now I know that my limit of my next one is equal to 1. So this whole thing is 1. So let's go down here. So I have sine x times 0, which is 0, plus cos x times 1, which is cos x. 0 plus cos x is cos x. So what did I just prove? I just proved that the derivative of sine x is cosine x. So now that I've proved it true for all values of x, I can use it for anything moving forward. So the derivative of sine x, cos x. So if this video helped, please give it a thumbs up and hit subscribe so I can help more mathies just like you. Thanks for watching, and I'll see you for the next one.